Hello and welcome to another Mr. Marriott's Maths video. This time we're trying question 2 from Leeds Maths School, Further Stats 1, Assessment number 7. So a study undertaken by Good Health Hospital found a number of patients each month, X, contracting a particular superbug can be modelled by a Poisson distribution of a mean of 1.5. And we're asked to calculate the probability that X is equal to 2. So first of all, we're going to write down our distribution. X is distributed Poisson, 1.5. We want the probability that X is equal to 2. So our calculators can calculate this probability directly, but we can also use a formula for a Poisson distribution, which is e to the negative lambda, so e to the negative 1.5, multiplied by lambda to the power of the outcome 2, divided by the outcome factorial. And if we evaluate this is going to give us 0.251 to 3 significant figures. Part II. I'm asked to determine the probability that exactly 2 patients will contract the superbug in each of 3 consecutive months. So we can model this as a binomial situation. So y is the random variable that a patient, counting the number of months where exactly 2 patients contract the superbug in a period of 3 months. So this is going to be a binomial 0.251 distribution. Because we've got 3 months and a probability of exactly 2 patients contracting the bug in each month is 0.251. We want the probability that y is equal to 3. We want the probability that this happens in each of the 3 consecutive months. This is equal to 0.251 raised to the power of 3, which is equal to 0.0158. Okay, moving on to part B. And we're now asked to write down the distribution of y. So really I should have used a different letter in A part 2. Let's just use a different letter now. I'm going to use the letter C. We're asked to write down the distribution of y, the number of patients contracting the bug in a given 6-month period. So I'm going to scale my Poisson distribution. If my mean rate or my constant average rate is 1.5 per month, my average rate is going to be 9 every 6 months. So y is distributed Poisson 9. Part 2. And I'm asked to find a probability that at least 12 patients will contract the bug during a given 6-month period. So I'm told to find a probability that y is greater than or equal to 12. Our calculators can calculate this probability directly, and if you ask it to do so, it's going to tell you that it's 0.1970. Or we can use probability tables for this as well. So this is the same as 1 subtract the probability that y is less than or equal to 11, and we're told this probability in our probability tables. It's 0.8030. And 1 subtract 0.8030 is 0.1970. Last but not least, we're asked to state 2 assumptions implied by the use of a Poisson model for the number of patients contracting this superbug. So we can say that the bug attacks patients independently of other patients. It attacks patients singly it attacks patients with a constant average rate. And last but not least, it attacks patients randomly. Or with a constant p. So where do the marks for this question come from? So you get a method mark for stating the distribution and an accuracy mark for getting the correct probability. The distribution is implied by the probability. For part 2, you get a method mark for using a binomial distribution and an accuracy mark for getting the correct probability again. And this is a follow-through mark, so if you've got the wrong probability in A, you can still get this mark if you get the correct answer for the probability in A part 1. For B part 1, you get an independent accuracy mark for getting the correct distribution, and then a method and accuracy mark for getting the probability correct. Last but not least, you get 2 independent accuracy marks, one for each assumption you make. So each of these 4 assumptions is valid. You get B1 for giving one of them, and a second B1 for giving a second one. If you give 3 assumptions, you can only score a maximum of 1 mark. So that makes this the end of the video. So until next time, thank you for watching and goodbye.